Hi, hello, my dear friends. Welcome to Unacademy. Welcome to today's session. In this session, we are going to continue the VLSM. The last session, we learned how to do VLSM. In this session, we are going to see that how the VLSM problems can be answered in easier manner. Before entering into the session, let us say all our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Myself is Srinivasarao Sir, having more than 15 years of experience in the GATE with the various subjects. I also had industry experience in the backend side, that is a database and networking. Dear friends, throughout journey of GATE, I taught in many premium academies with a high success rate. Many of my students got settled in topmost positions just by completed their post-graduation from India's premium institutions. They are IIT and IIT Central Universities. This is all because just by cracking GATE examination. So you also can do such kind of things, and you also can achieve such kind of goals and your dreams just by having a proper guidance and a proper shortcuts and tips. Dear friends, Unacademy is going to provide such kind of guidance and shortcuts and tips which are very helpful to clear your GATE examination. There are two varieties of courses are available according to GATE and ESE concern, Plus and Iconic. So you can opt for either Plus course or Iconic batch. So Plus course, there are three varieties of subscriptions like this. So you can use any of the subscription, but current second and third and fourth year and first year students can go for long-term coaching, that is a 24 months and 18 months, where you are going to get multiple number of sessions and multiple number of classes, which are going to prove you much more confidence. And if you use my referral code, so use my referral code, then you are going to get a maximizer discount. Well, my dear friends, after applying my referral code, then you are going to get three varieties: 12 months and 24 months and 18 months subscription as like this. So my referral code is eligible for any kind of a course, not only for GATE ESC. And if you use my referral code, then I can able to give you my complete guidance, because as you are going to be admitted under me. And the other one is Iconic subscription. There are two varieties, 12 months and 24 months. So here also my referral code is applicable. Use my referral code, then you are going to get it for this is the price. Okay, my dear friends, let's crack GATE CSE is our YouTube channel. Subscribe our YouTube channel and get the many more things. Get the many more things. Use my referral code to get the admission into Unacademy. Hit the bell icon for latest notifications and updates. Now here I am going to present the problem session on VLSM. So for example, last session we learned that variable length subnet masking is nothing but we are going to do outermost part and innermost subnetting. So when you are doing outermost part, then we are going to get one kind of subnet mask, and when you are doing innermost subnetting, then you are going to see that another kind of subnet mask. So how are to be done these things? I'm going to explain in this session, along with random splitting also I'm going to show you. Random splitting is nothing but non-uniform splitting. I will show you in this session. So please be ready. Let's crack this. Consider class C network is asking you to propose an appropriate subnet mask to have 60, 60 and 120 HIDs, right? So this is the figure here that one network outer network is going to have 120 HIDs, and this outer network is going to have 120 HIDs. Further, this is being split into two more parts because the first subnet group needs 60 HIDs, second subnet group needs 60 HIDs, and third subnet need 120 HIDs. Okay, my dear friend. So how to do? Let us see now. So first, the rule number one is we have to do outermost split. Therefore, if you do one bit splitting, then it is going to give you 2 power 1 subnets. That's it. Our motto is satisfied. What is our motto? Your outer split has got 2 parts. So that means I am doing 1 bit subnetting here. So I will show you when you do 1 bit subnetting according to class C, there are 7 HIDs are possible which are segregated in first group and others are segregated in second group. Therefore, what happened? If I am saying that your class C can give you 256 HIDs and they are being divided into 2 parts. So one part is giving you 128 HIDs and other part is giving you 128 HIDs. So therefore, the first subnet, again it is a further innermost splitting. So we are going to get subnet 2 and subnet 3 from your subnet 1. But subnet 2 is as usually, what is that? It is not going to do any kind of further splitting. So our main intention is that this one is our main intention. So how to do this? I am going to do 1 bit subnetting. I am going to do 1 bit subnetting of your class C. Therefore, my dear friends, the default mask of your class C is NNN and HID. Therefore, 255 and 255 and 255 8 zeros. This is your default mask, right? I am doing a 1 bit subnetting over there. So by taking a 1 bit subnetting, then the rest of the part is your HID only. So how many bits I made? How many bits are reserved for HID? There are 7 bits are reserved for HID because this is being masked to 1. So what is your new mask? Your subnet 1 got a mask 255.255.255.128 and your subnet 2 also got, that means this side, right hand side subnet I am talking. Your subnet 2 also got same mask, that is a 255, 255, 255 and 128. Now we want to split this subnet 1 as S21 and S31. They are belongs to subnet 1 only. I am naming them as S21 and S31. That means innermost you need 2 more parts. Therefore, what happened? This is a further extended. This is a further extended that 255 and 255 dot. It is given as 1 0 and remaining all zeros. I have copied exactly. Now this bit again I am making a subnet because innermost splitting I am doing. So when you do innermost splitting, so this bit is under splitting. So when you do splitting, then what is going to happen? This becomes 1. So what is your new mask now? Your new mask after doing 1 bit for outer and 1 bit for inner. It is a 255.255.255.192. So that's what the question he asked. What is the question? What are the appropriate masks you want to generate? So we got two masks. One is n dot n dot n dot 128, and the other one is 255.255.255 dot 192. So this is how you can able to do under class C network. This is very important because subnetting mainly playing a role that only on HID masking from zeros to ones. Okay. So here only one bit we are taking because only outermost I need. Here two bits I took. Why? Because one is for outermost and one is for innermost. Let us look at. This is another beautiful question. So four subnets I need. Subnet 1 and subnet 2 and subnet 3 and subnet 4. What he is asking? Appropriate subnet masks he is asking. So appropriate subnet masks are nothing but how many HIDs you need? 75. How many HIDs? 35. How many HIDs? 25. How many HIDs? 18. So four subnets and each are having a different varieties of HIDs sizes. That's why we are named it as, and it is named it as VLSM. Who is going to do all these things? IANA, Internet Assigned Numbering Authority, is going to do this VLSM, FLSM, supernetting, subnetting, and IP allocation. All is done by IANA only. Right? Now tell me, let us answer our questions. So subnet 1 need 75 HIDs according to class C. Now tell me 75 HIDs. HIDs are nothing but 0 positions in your mask. 0 bits in the mask. Right? Now tell me how many zeros you need in the mask. Log base 2 of 75, which are nothing but 2 power 7. So 7 zeros required. Therefore, your default mask is 255, 255, 255 and 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros are there. So 7 zeros we want to reserve for HID. That's it. This is the concept, right? This bit is manipulated as 1. So what is your mask? Your mask is 255.255.255.128. This is the mask for the first subnet one. Right. And we want subnet 2 with 35 HIDs. Subnet 2 with 35 HIDs. Again you need to do, what is that? What is your class C default mask? Your class C default mask is 255.255.255. So 8. Now tell me 35 HIDs only I need. So how many zeros you required? Log base 2 of 35 is nothing but 6-bit subnetting. Right? So 6 bits we required for HID. 6-bit HID. Therefore, out of your 8 bits, 6 bits I am reserving for HID and remaining are for ones. Now what is your new mask? Your new mask is 255.255.255.192 because 128th position and 64th position, both are masked. Okay. And next one is 25 HIDs I need. 25 HIDs. Again, I am telling you HID is nothing but zeros in the mask. Right? So log base 2 of 25. So how many zeros you required? 2 power 5 greater than is equal to your 25. Therefore, 5 bits are needed for HID. Right? So let us write your default mask. Your default mask is 255.255.255 and which consists of 1, 2, 3, 4, 5, 6, 7, 8. And now you tell me how many bits are reserved for HID? 5. This is your HID reserved and the remaining are going to be ones. So what is your new mask? Your new mask is 255.255.255.224. So one of our friend is asking a doubt. Why sir 0 is? So 0 is masked means here according to that. This is your NID part, this is your NID part, this is your NID part. And the complete 8 bits are according to class C is HID only. So you are asking bits, you are asking 5 zeros means remaining are automatically ones. So when you making over zeros to ones, it is nothing but what? You are indirectly doing a what? Subnetting only. Right? So you cannot consider this is a n because if it is a slash n, that means if it is a CIDR, I can able to do that. This is completely network part only. But this is not CIDR. It is a classful addressing. Hence first 3 octets are net IDs and the remaining bits I am converting from zeros to ones because only I need 5-bit zeros. Therefore what happened? They are going to be what? Subnetting. Right? And come to the next one. What is our next one? I need 18 HIDs. So 18 HIDs I am taking. So 18 HIDs in your class C. It is a triple N.H. Therefore, it is 255.255.255 and they are going to be 8 zeros. Now 18 HID I need. So log base 2 of 18 which is nothing but 2 power 4 is not greater than your 18. So we want to go for higher one. 2 power 5 greater than 18. So as it is like previous, I am taking 5-bit zeros. Therefore, your new mask is 255.255.255. You reserve 0 bits, only 5. So rest of the HID bits are going to be converted into ones. So which I am calling them as a what? Subnetting. So that's it friends. These are how the appropriate masks we are being given. So ultimately last session I told you how to identify what? Subnet IDs also. You are going to get different subnet ID and you are going to get different subnet ID for every group. Right? Don't forget that. So let us see. This is the question. Very similar question now. We want to identify the answer. What is that? Please look at 72 HIDs. 72 HIDs is nothing but 2 power 7 is nothing but 128, which is greater than your 72. So I am doing 7-bit zeros. When you do 7-bit zeros, your default mask is 255, 255, 255, and only I am keeping 7-bit zeros only. The remaining 1 bit is 1. What is the meaning of this into decimal? 255.255.255.128. Come to 35 host. 35 host means we want to take 2 power 5 is not satisfied there. 2 power 6. 2 power 6 means 6 zeros and double 1, which is nothing but 192. And 20 host. 20 host is nothing but what? 5-bit HIDs. And remaining 3 bits, 3 ones. So 3 ones is nothing but 224. And 18 host IDs, same 5 bits zeros. And it is also what? 224. So according to that, your answer is what? A. So let us do this. So this is a very interesting question. You might not have seen in the FLSM and VLSM because I want to present non-uniform splitting in this example. Very rarely you will find these questions, but very important. In 2003, you have got question on this, right? So observe carefully. Now he has given class C network only, that is 192, 168, 100.100, and mask is given as 255 and 255, 255, 130. Observe carefully. So we understand according to the class C, first 3 octets are NID and the last octet is HID, right? This mask HID is manipulated. Instead of 0, there is some other number, non-zero value is there. So when HID is manipulated, we understand it is subnetted. If NID is manipulated, it is supernetted. Please understand carefully. If NID is manipulated, it is a supernetting. If HID is manipulated, it is a subnetting. Please watch my continuous IP addressing lectures. Further, 4 more lectures are there. Please follow them. So NID is manipulated means supernetting. HID is manipulated means subnetting. So we understand it is subnetted. How it is subnetted? So I am going to write your 130 into binary. How it is? 128 is on, 64 off, 32 off, 16 off, 8 off, 4 off, 2 on, 1 0. So this is your subnet mask, how it is manipulated. So what do you understand? 1 indicates subnetted, 0 indicates host, right? Therefore, this 128th position is subnetted. So 128th position is subnetted and the 2 position is also subnetted. Okay, all together it is 130. There are no other alternatives to this question. Now you listen carefully. How many number of subnets are there? This is the first question he is asking. As many number of ones are there in your HID part, those many number of subnets. So your number of subnets, according to that, I am doing non-uniform splitting. Observe carefully because zeros are separated your ones. If it is FLSM, consecutive ones you will have from left towards to right. It is not FLSM. I am doing non-uniform splitting. Now tell me, 2 power 2 ones are there, hence you are going to get 4 subnets. What are your 4 subnets? That's what he asked you. Now, what are subnet IDs? And second question also you can answer. What is that? Number of HIDs. As there are how many zeros? So 6 zeros are there. 1, 2, 3, 4, 5, 6 zeros are there. Your number of HIDs is 2 power 6 minus 2. Okay. So that is nothing but 62 HIDs. This is the crucial question. Subnet IDs and subnet broadcast address he asked you. So I'm going to write the subnet ID. You want to write the subnet ID? Take the given IP. What is your given IP? 192.168. 100.100. Okay. So we are going to drop as it is the first 3 octets as it is belongs to NID. This is your HID. So 4 subnets I am asking. So 4 times I am dropping it. Last octet value can be anything, don't worry. But if it is a given how to identify answer, I will show you. 4 subnets I have written. This is a subnet 1. This is your subnet 2. This is your subnet 3. This is your subnet 4. How did you get 4 subnets? Because you know 2 power 4, 2 power 2, 2 bits are subnetted, therefore you are going to get 4 subnets, right? But hosts are going to be variable because you are not going to see that same number of hosts in this. So now let me tell you 100 binary first. What is your 100 binary? Please observe. So I am taking first of all 0, 0, 0, 0, 0, 0, 0, 0. So 2-bit subnetting position I am showing you. This bit is manipulated and the second position bit is manipulated. Okay. So we are not going to disturb them. It is your subnet ID. This is also subnetting position only. Now 2 power 2, 4 combinations you need to write. What are your 4 combination? 0, 0, 0, 1, 1, 0, 1, 1. So you got 4 combinations. So the first combination is 0, 0 I am using. Second combination, wherever you have got subnetted, there only you need to write 0, 1 I am saying. And 1, 0 I am saying. 1, 1 I am saying. So rest of the bits are HID. We are not going to disturb. We are not going to disturb as they are representing HID only. Now tell me what is your first subnet ID? Last octet I am talking. This is all zeros, right? It is a 0. Here, what is this value? 1, 2, 4, 8, 16, 32, 64, 128. So second position is on. So next subnet is 2. And the next subnet, which position is on? 128 is on. So 128 you drop. Next 128 plus 2, it is 130. That's it. You got your answer. Now tell me, this 100th host belongs to this particular network because it is one of the IP in between 2 and 128. So here the hosts are going to be variable here because here 0 to 1 is your host ID, 2 to 127 is your host ID, 128 to 130 is your host ID. This is one of the big drawback of your VLSM, that is a non-uniform splitting. You will not get equalized number of HIDs as like your FLSM. That's why VLSM is a utter flop. Only we are using it right now in the current operating system and our current internet era. We are following FLSM only, either for subnetting as well as for supernetting. Both we are using FLSM. Now You can also do in a shortcut, because he asked about this IP, right? What is the IP? 100 IP. He need to have subnet ID and subnet broadcast address. So 192.168.100, they are your network IDs, and this is your HID. Write 100 in binary. So 01100000100. This is your 100 binary I have written now. Now, which are the bits are subnetted? What are the positions are subnetted? You know, 128 bit is subnetted, right? And the second position is subnetted. Please recollect the previous slide. What is that? Your mask 130 is subnetted in such a way. First bit is subnetted and last before bit is subnetted. So you need to give a gap. First bit is subnetted, don't disturb, and last before bit is subnetted, don't disturb, as it is subnet ID. So your subnet ID is that 192.168.100. So drop this as it is. We are not going to disturb. Drop this as it is. We are not going to disturb. And now convert your HID positions to 0 to get the subnet ID. Convert your HID positions to what? Ones to get your broadcast address. Right? Now let us do another question. So 15 and 19 we want. So this is how. Please observe carefully. Now he moved on to class B. So earlier we completed class C. You want to one more example I can give you. For example, let us say 200 point and 200 point and 100 point, something like 130. And your mask is given 255.255 dot and 255 dot, something like 194. So if you take this and this is your HID. So write this 194 into binary. So 128 and 164, 192. Yeah. Now listen carefully. So 192 and 2, it is a 194. That means this bit is subnetted and this bit is also subnetted. So 128th position, 64th position and second position is subnetted. Right? Now you know that the first two questions, what is that? Number of subnets, 3 ones, 8. And number of HIDs, 5 zeros. And he is asking subnet ID. Write your IP to get the subnet ID. So first 3 octets we are going to drop as it is. So 130 you go right into binary. What is a 130? 128 is on and 2 is also on. Right? So what are the positioned, subnetted position? According to this, first 2 bits are subnetted and the last before bit is subnetted. You drop them as it is. So 200 point, 200 point, 100 point. So you drop as it is 1 0, and remaining you convert them to zeros. This is also as it is 1. So the remaining are zeros. They are all for HID only. Now you see 200 point, 200 point, and 100 point. You drop as it is subnetted positions. Remaining you make them to ones. So read what is the value. What is the value? So 1, 2, 4, 8, 16, 32, 128. So 255 minus 64, that's the meaning. 255 minus 64, it is 191. Okay, so this is the concept. Now let us apply the same for class B also. So according to class B, if you looks like, it is NID, NID, HID and HID. So what is our value? It is given in the form of 172, 168, 100.225, and your mask is given as 255.255.255.18. So let us see that this and this, instead of zeros, they are being masked with some number, right? So 255 means 8 ones are subnetted, FLSM fashion. And what is 18? So 128 is off, 64 is off, 32 is off, 16 on, 8 off, 4 off, 2 on, and 0. So these are all subnetted positions only. This is a completely subnetted, and in this bit is subnetted, and in this bit is subnetted, right? So how many zeros are there? 2 power 6 zeros. This is for HID. And how many ones are there? 8 plus 2, 2 power 10 subnets are there. Okay. Now listen carefully. What is your subnet ID? So write the given IP. What is the IP? 172.168.100. What is the given? 225 given. So the first two octets are N and this is going to be H. So write those two into the binary. So 100 binary, 0 1 0 double 1 0, 0 1 double 0, and 225 binary. So 224 and 1, 225. Now what are the positions, subnetted position? So these are all subnets only. And what else are subnetted? Fourth and seventh position. So you mark them, they are the positions. Now you want subnet ID, drop subnetted positions as it is. And this is also subnetted only. Remaining you make them to 0. This is also subnetted. And you want subnet broadcast. So drop as it is. And reminding you make them two ones. So this is your answer. Okay. So put this subnet ID and the subnet broadcast address into the respective positions. The same you can also do for class A. What is your class A? It is N with a triple H. Observe carefully. This is the last model which we are going to close. N with a triple H. Now here what happened? It is a 10 with 16 dot, 100 dot, 242. Your mask is 255, 255, 255, 128. So this is subnetted completely. This is subnetted completely. And this is 18. No? So this is somewhat non-uniformly it is subnetted 1.8. So let us write these three into the binary. So here 8 ones are there. Here also 8 ones are there. 18 means 16 plus 2. This is your 18 binary, right? In the last octet, this is subnetted and the next bit is subnetted. So you want subnet ID. What is your subnet ID? So you can say that number of subnets, first question, 8 plus 8 plus 2, 2 power 18. Number of HIDs, 2 power 6 minus 2, because 6 zeros are there. And what is your subnet ID? Write your IP into the binary. 10 point, 16 point, 100 point, 242. Right? So this is completely subnetted. This is a completely subnetted. In this only 2 bits are subnetted. 2 bits are subnetted and 6 bits are zeros. So therefore you will get as it is 10 dot, 16 dot, 100, because anyhow you are going to drop them, the subnetted one. So let us confirm 248, 242 into binary. 242 means, so 224 plus 18 we want. It is 242. So 224 means triple one. 18 means 128, 64, 32, 16, 8421. This is your 242 binary, right? So what are the bits? What are the bits are subnetted in 18? Fourth bit and before last bit. So this is subnetted and this is subnetted. So drop remaining and convert them to zeros and the ones. So drop it. This is subnetted and this is subnetted. Remaining you make them to zeros. And remaining you make them to ones to get the broadcast address. That's it, my dear friends. So this is how you can do the non-uniform splitting, which I want to put it under VLSM because it is going to give you different varieties of host ID positions. So this is how you can find your subnet ID and you can find your subnet broadcast address. Your subnet broadcast address is 10 point, 16 point, 100 point, all ones. And this is 18. Now So differently he is asking. So we need to be very careful about these kind of questions. Class A, but differently, not completely they have subnetted. They are split and subnet in the octets. So let me write first of all N with triple H, and your IP is 10.32.102.109 with a mask 255.240.240.130, right? So this is masked completely. So let us see that how it is masked. That's very important. So 240 means 4140s. Here also 240 means 4 ones 4 zeros. Here 130 means 128 and remaining all zeros and 2. So this is how it is being masked. Now tell me, from this I can answer number of subnets. They are so 8821 ones. So total ones are 2 power 10. And number of HIDs. How many HIDs are there? 8. 4 plus 4, 8. 8 plus 4, 12. 12 plus 2, 14. 2 power 14. Minus 2. So we want to find a subnet ID to this and a subnet broadcast address. So write your IP 10.32.102.129. So this is your N and remaining all are H only. But how it is subnetted, let us see. Write 32 into binary. 128, 64, 32, 16, 8, 4, 2, 1. And 102 binary. 102 binary. So 102 means 96 plus 6. Therefore, 96 means 0, 11 and 0. So 128, 64, 32, 16, 8, 4, 2, 6 and 0. And 129 binary 1, 1. This is a 129 binary, right? So this is the first octet is a 10, second byte is 32, third byte is 100 and naught, and next byte is 129. So what are the bits are positioned? What are the bits are subnetted? That's very important. In second octet, first 4 bits. In third octet also first 4 bits. And in last octet, you observe carefully. Last octet, first bit and last before bit. Okay. So remaining make it to zeros, remaining make it to ones. Bus. Remaining you drop. As it is, you drop. Make them to zeros. You drop as it is. Make them to zeros. And you want broadcast address 10 point. Drop it as it is. Make them to ones. Make them to ones. Bus. How simple it is, my dear friends. So VLSM also can be done very similar to FLSM, but please be see that you need to write IP path and see that what are the subnet positions are happened. So leave those positions, make them to HIDs and make them to HIDs to zeros and make them HIDs to ones. So very important topic which was not asked so far after 2003, but very important questions there. Now let me do it differently this time. So class B network with VLSM is asking write appropriate masks. Write appropriate masks. Can I generate these many HIDs in class B? This is the first question. Can we generate how many altogether? 2000, 3000, 6000, 5 plus 6, 11,000. Can we generate 11,000 HIDs in class B? Yes, because class B can give you 65,536 HIDs. No problem. You can happily do it. So 2000 HIDs means how many zeros? Simply I am doing. Please follow me. 2000 HIDs means how many zeros? 2 power 10 means 1000 roughly. 2 power 11 means 2048. So we need 11 zeros. For first group, 11 zeros we need. Okay. And 3000 HIDs you need, which is nothing but 12 zeros we need. And 6000 HIDs I need. 6000 means 2 power 12 means 4000. 2 power 13 means 8000. That's it. You need from this 13 zeros. That's it. Write the masks of it. So what is a class B default mask? Your class B default mask, if you know, I can do the remaining. What is your class B default mask? 255.255.1234567 1 2 3 4 5 6 7 8. This is completely HID part only. This is NID, this is NID. So for first subnet 1, how many zeros you need? 11 zeros I need. So 11 zeros I am taking. So remaining all ones. 5 ones means it is 248 plus 0. So 255.255.248.0. And subnet 2. Again I am taking default mask. 255.255.1234567 and 8 zeros are here. So 12 zeros I need. And the remaining are going to be ones. So what is the meaning of it? 240.0. And subnet 3, when you say, please understand, your default mask is 255.255.1234567 1 2 3 4 5 6 7 8. So 13 zeros we want. So 8 plus 5. Better you take always from right to left HID positions. That is a good behavior. That means a good working principle. So 255.255.224.0. That's it, my dear friends. So this is how you can able to solve your requirement. This is my requirement. This is how the Airtel people and BSNL or Jio people will request to the ISP, Internet Service Provider, that is under with the government of India. So they are going to allocate pool of the IPs to them. Those IPs are distributed to individual customers like us. So the last variety before closing VLSM part 2, last variety, you know this task. What is that? Class A, I can do very simply. Class A means N with a triple H. It can generate 2 power 24 minus 2 HIDs, very, very huge. And I want to use it for 3 different parts. This one, 10,000. 10,000 means how many HIDs, my dear friends? 2 power 10 means 1000, I say. 11 means 2000. 12 means 4000. 13 means 8,000. 14 means 16,000. Now you see how many zeros you need? 14 zeros you need. So you know what is the mask now. 14 zeros you need. So here 15,000 HIDs. So here also same. 14 zeros I need. And 20,000. So therefore 15 zeros we need. That's it. Please write the mask on your own. What is your new mask for this group and this group and this group? For this group, mask is same because 14 zeros only. This and this mask is same. But this one, 15 zeros you need to write. Please see that the default mask of your class is 255 0.0.0. So leave first 16 zeros, 14 zeros for two groups and 15 zeros for third group. So well, my dear friends, and the next session we are going to see some of the very important numericals which I not discussed in the previous YouTube sessions. I'm combining this time FLSM and VLSM so that before closing your subnetting class full addressing, you will be having a very good grip. So tomorrow again we are going to meet at the same time 7 p.m. to 8 p.m. We are going to see the complete numericals, very important numericals which I not discussed in the earlier sessions based on FLSM as well as VLSM. So don't miss any of my classes. This is my humble request because to get the knowledge you need to have the continuous listening of the lecture. This is almost all 30th lecture for me. If you missed any of my previous classes, please watch them. Acquire the knowledge. It may be helpful in some other place. It may be in a GATE or it may be in the industry. If you come into the networking part, for example, Geo is giving a much more openings and BSNL is giving much more openings for CS guys. So you need to have this addressing concept. Geo is completely based on IP addressing and configuration of routers only. That's why I'm going in depth elaborately. If you are having any doubts, you can ask me or mail me. You also please follow special classes which I am running on Unacademy. That's very important because some of the concepts and problems which I am not discussing on YouTube, I am discussing on Unacademy student learning app. Please follow them. Tomorrow, I am going to conduct a special class on IPv4 header. Don't miss. So timing I will tell you. So the IPv4 header, I'm going to do 1 hour class, maybe afternoon session I'm going to discuss. So please download Unacademy student learning app. Along with this YouTube lecture, you also please practice them. Then you will be having a good grip. So you also can become a mentors and you can also start teaching yourself. We will meet in the tomorrow session. And this knowledge is very much useful while you are writing Microsoft Certified System Admin and Microsoft Certified System Engineering certifications and Cisco certification. This knowledge is very much useful. Completely IP addressing only. Okay, my dear friends. So we will meet in the tomorrow session, special class as well as YouTube session. So YouTube session is as usual 7 p.m. to 8 p.m. only. And a special class, maybe I am planning to conduct 4 to 5 or 5 to 6. So please watch for it and see that your IPv4 header questions, how they are going to be asked in the exam, you will come to know. Thank you very much for sparing your valuable time.